Section 4.4 Zeros of Polynomials. In this section we're going to learn how to find zeros of polynomials. Before we do that, let's quickly recall or review some of the concepts we've learned so far. Okay, so this is just a quick review. Okay. So let's start with this. Okay. Let's say that if I given a polynomial function like this, x cubed minus 3x squared minus 2x plus 6, and what we want to do is we want to find the zeros. Basically, what does that mean, to find the zeros? We learned earlier in section 4.2 that finding the zeros is the same thing as trying to solve this when p of x is going to be 0. Okay, so let's take a look at what all of that means before we proceed further today. What does it mean to solve this equation? Let me write it that way. This implies solving p of x is equal to 0. We want to solve this equation. In what other contexts have we come across that equation? Okay. By the way, zeros is the same thing as roots. Okay. So in this case, if we solve this equation and find the value of x for which this p of x is 0, then we call x the zero of that polynomial, that value of x, or the root of that polynomial. Another word we can use for that is, because we are taking p of x and setting it equal to 0, we can think of this as, remember we talked about this before, p of x can also be replaced with y when we're graphing. So in essence, what are we doing here? We're setting y to 0. When do we set y to 0? When we're graphing, when we're trying to find the x-intercept. So finding the zeros is also the same thing as finding the x-intercepts. Okay, so those three things all mean the same. Okay, and anytime you're solving something, we're really trying to find the solution. So we're really also trying to find the solution to the equation, this particular equation. So you can also think of that as finding the solutions. So finding the zeros in a way means finding the roots, finding the x-intercepts, or finding the solution to an equation. They all mean the same thing. So let's go ahead and do this problem. So I'm going to find the zero, so I'm going to take my polynomial and set it equal to 0. So I'm going to take x cubed minus 3x squared minus 2x plus 6 is equal to 0. Okay. Then we're going to go ahead and try to solve this. And when we're trying to solve anything that's degree 3 or higher, the only way we can do that is by factoring it. Okay, unless it's one of those special equations where that has 3 terms and somehow you can change it to a quadratic. This has 4 terms, so we can't change it to a quadratic even if we wanted to. So if you have 4 terms, how do we factor? We group the first two and the last two. In the first two terms I have an x squared, so I get x minus 3. In the last two terms I have a negative 2 common. Remember, the negative sign comes out, so I'm left with x minus 3 is equal to 0. What's common in these two terms? There's an x minus 3 common, so I get x squared minus 2 is equal to 0. This product is 0, so what does that tell me? One of them has to be 0. X minus 3 is 0, or x squared minus 2 is 0. So we get x is equal to 3. So that's one solution. Out here we have a square and a number, so we solve that by moving the number to the other side and introducing square roots. So we get plus or minus square root of 2. Okay, a while back we learned that the degree of the polynomial tells you how many zeros you're going to have. We have 3 zeros here we found, and the degree of the polynomial was 3. Okay, so now that we have that, we know how to do that. Let's take a look at something else that's interesting. If I were to take this 0 of 3 and divide this polynomial by that 3 using synthetic division, I have 1, negative 3, negative 2, 6. So if I do that, it goes into that, we put 0 in the first column, we get 1, 3 times 1 is 3. We get 0, 3 times 0 is 0, we get negative 2, 3 times negative 2 is negative 6, we get 0. So if you notice, once the zeros of the polynomial, if you find the zeros and divide the polynomial by that, the remainder is always going to be 0. And then what are we left with? We started with degree 3 polynomial, so these are the coefficients of a degree 2 polynomial. So we're left with x squared, there's no middle term, minus 2. That's my quotient. Okay, so that's what we are left with, and that's exactly what we had on this side, if you notice. Okay, so anytime you find a zero of a polynomial, you see that the remainder, if you were to divide that polynomial by that number, the remainder is going to be 0, and then what's left will be the x squared minus 2. And why is that? Well, that's because what we talked about earlier when we talked about factors and things like that. If you recall, if I divide n of x by d of x, we end up with what? Q of x plus r of x, the remainder times d of x. And if the remainder is 0, this term is gone, so we end up with what? N of x is equal to, you can cross multiply this, q of x times d of x. And if d of x is something nice, a linear function, then we end up with q of x times like x minus c or something like that. So that's what it looks like. That is if d of x is a linear divisor, you're dividing by x minus c. So you can see my original polynomial p n of x can be written as the quotient times the divisor. And if divisor is nice like this, we can write it this way. Okay. And the other thing also, this is just some stuff I'm bringing back to your memory. The other thing also to note is if r is equal to 0, the remainder is 0, then that tells me what? Then d of x is a factor of n of x. We talked about that, and you can see that right here, because n of x can be factored into these two, and one of them is d of x. Okay, and if x is equal to r is a 0, okay, of n of x, then x minus r is a factor of n of x. Again, we've talked about this before also. You move this r to the left hand side and you get a factor. Okay, so these are just some of the things I'm bringing back, because we're going to come across all of these today when we try to find the zeros of a polynomial. Just a quick review of things we've already done. Okay, alright, so let's take a look at what we want to do in this section. So we want to find the rational zeros. Now I'll capitalize this word because this method that we are talking about today only finds the rational zeros of a polynomial. So this method only finds the rational zeros. Now obviously, if you go back to the previous example, this method that we're going to talk about will find this 0 but not this one, because this is an irrational number. Square root of 2 is not a rational number. So let me quickly remind you what a rational number is. Rational number is anything that can be written as a fraction. That is anything that can be written as a over b, where b can be 1. Okay, so anything that can be written as a fraction is a rational number. So this method will only let us find zeros that look like this. So if you have a 0 that has a square root, it's not going to do that. Okay, so just bear that in mind. So how do we go about doing this? Here's the method that you want to follow. The first thing you want to do is, let's say if you're given a polynomial like this whose zeros you want to find, some p of x, you have an times x to the n plus an minus 1 times x to the n minus 1 plus a2x squared plus a1x plus a0. I'll call this the last term and this the first term. Okay, and I'll first term coefficients, last term coefficient. Okay, so the first thing we want to do is to find the zeros of this polynomial. What we want to do is find the factors of the last term coefficient and the first term coefficient. We want to do that. Okay, we want to find all numbers that divide this number and this number. Okay, then our list choices for zeros, choices for the zeros of p of x are, okay, I'll call the zeros x because 0 is going to be some value of x for which that's going to be 0. It's going to be x is going to be the last term coefficients divided by the first term coefficients. Those are our choices. Okay, and then the next thing we want to do is, once we have a list of choices, okay, we start dividing. How do we know which of these is 0? Once we have a choice, let's say I have 10 numbers, out of which 3 of them are going to be my zeros. How do I know which one is your 0? What did we just learn? If something is a 0, then when you divide synthetically, what happens? The remainder is going to be 0. Okay, so then we divide the polynomial p of x by the choices for x for 0 in step 3. Okay, if the remainder is 0, then that value is a 0 of the polynomial. Okay, and then what do we do? Well, we found 1 0. What if the degree of the polynomial was 4? So that gives me 1 0. I still have 3 other zeros to find. Then what do we do? Then repeat the above steps for q of x, the quotient from step 3. After we divide in step 3, we'll end up with a quotient, so we repeat the above steps for the quotient from step 3. So this is a tedious process, but it, like I said, it works really well. So it's a good way to find the zeros, because there's really no other ways to find the zeros of a polynomial. Like for example, in this polynomial here, the one that I started with, if I just switch this to a minus there, then this would become a plus, and these two would not be the same. Then I wouldn't be able to do any of this. Okay, so then I would be stuck. So how do I find a 0 of something like that? Okay, so that is a key over here. We need to have a method to find zeros of polynomials that you cannot factor, because if I cannot factor this, I'm stuck. So anything degree 3 or higher and you cannot factor it, then you have to use this method to try to find the zeros. Okay, now before I go further, let me give you a little trick to help you narrow down the list of zeros. And this doesn't always work, but it's a good place to start. Okay, alright, so let's go ahead and take a look at an example, and I'll give you a little trick on how to do that. So let's say if I have, okay, p of x is this. I have 3x to the 4th, okay, plus 23x cubed plus 56x squared plus 52x plus 16. So I want to find the zeros of this polynomial. This is degree 4, so the only way I can find the zeros is by factoring, and there's no way to factor this, okay, that I know of. And so it's going to be a problem to find the zeros of this by factoring. So let's take a look at this method. What does this method tell you to do? The first thing it tells you to do is it tells you to take the last term coefficient and find the factors of it, and the first term coefficient and find the factors of it. Okay, So in our case, the last term coefficient is 16. So what are the factors of 16? What numbers do you divide, okay, to get 16? Okay, I'm sorry, what numbers divide 16? I'm sorry. So it's 1 divides 16. But think about it, if plus 1 divides 16, so does minus 1, so we have to include both. Then 2 divides 16. If plus 2 divides 16, so does minus 2. Then 4 divides 16. Then 8 divides 16. And 16 divides 16. So those are my factors of 16. Let's take a look at the first term coefficient, which is 3. What divides 3? 1 always divides everything, and so does minus 1, and then plus or minus 3. So what are the choices of our 0? Choices for zeros. Now remember, these are the choices just for the rational zeros. We talked about this, okay, and I'll show you that in a second. What do? We take our choices x are going to be what? You take the last term coefficient and divide by the first term coefficient. So my choices are going to be x's, so I take all of these last term coefficients and divide by 1. If you divide anything by 1, we just get that back, so we get that whole sequence back. Then you take the last term coefficients and divide by 3, so we get 1/3, 2/3, 4/3, 8/3, 16/3. So these are all my choices. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have the negatives also, so you have 20 choices. So we have a total of 20 choices. Out of those 20 choices, how many zeros am I looking for? 4. Now, the zeros I'm looking for don't all have to be rational. Some of them could be complex, so you have to be careful, or some of them could be irrational, and so on. Okay? So that's something you need to watch out for. Okay? But there is a nice little trick that'll help us narrow this down a little bit. Okay? So let me show you that trick. This is not in your notes, but you can use this trick to narrow your selection down. I have 20 choices. I want to cut it down. Okay? So what I want to do is use something called Descartes' sign rule, which basically tells you to find the number of sign changes from term to term in the polynomial p of x and p of minus x. So I have to find the number of sign changes from term to term. So let's look at the p of x. P of x is already given to us, and we'll have to find p of minus x in a second. So remember, this starts with a positive 3. So the question is, does the sign change from positive to negative here at all? No, the sign doesn't change. Okay, from here to here the sign doesn't change, it doesn't change, so it doesn't change. So there's no sign changes in p of x. So I'll just say p of x, and that's a positive sign changes because we're looking at positive x. So positive sign changes is equal to 0. There's no. Okay. Now let's figure out the negative sign changes. To find the negative sign changes, all we have to do is replace this x with minus x. So we get p of minus x. So we get 3 times negative x to the 4th plus 23 times negative x cubed plus 56 times negative x squared plus 52 times negative x plus 16. Okay. So let's see, we end up with 3x to the 4th, because any number to the any negative number to the even power is just positive. Then we get 23x cubed. Any negative number to the odd power is negative, plus 56x squared minus 52x plus 16. So how many times is the sign change in this problem? If you notice, we start with a positive here, we go to negative, so there's one sign change. We're looking for sign change from term to term. From here we go from negative to positive, so that's 2 sign changes. From positive to negative, 3 sign changes. And from negative to positive, 4 sign changes. So there's 4 times the sign changes. For example, if this was positive, then there would be no sign change from here to here and from here to here, so then there would only be 2 sign changes. But in this case there is 4. So the number of negative sign changes equal to 4. Now here comes the goofy part. Okay, if you recall from earlier, okay, if I have a polynomial whose one of the zeros is this, let me actually give you an example just to show you. Let's say if I have p of x is equal to x squared plus 4. Let's find the zeros. What do? We take a polynomial and set it equal to 0. I have a square and a number, so we move the number over. We get negative 4. Then we introduce square roots on both sides. We have to introduce plus or minus square root of negative 4, which we all know can be written as 2i, because it is square root of 4 times square root of minus 1. This is 2 and I. The plus or minus comes from the square root theorem. So if you notice, we found 2 solutions. One is plus 2i, one is minus 2i. Okay, so usually whenever we have one of the zeros is complex, then the other one is then we're going to get another zero that's also complex, the conjugate of the one we found. So the complex zeros always go in pairs. Okay, always remember that. Like here's another example just to prove the point. Let's say if I have p of x is equal to, okay, we have x squared minus 2x minus 4. Okay, so this cannot be factored, so I want to use the quadratic formula. So we get x squared, we get negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So we get 2 plus or minus square root of negative 2 squared is 4. Okay, and this I wanted it to be positive. So we get negative 16 over 2. So we get 2 plus or minus square root of negative 12 over 2. 2 plus or minus square root of negative 12 is square root of 4 times 3 times square root of minus 1. And square root of 4 is 2, so we get 2 square root of 3i over 2, and we always write a complex number separated by real and imaginary parts. So 2 over 2 is 1, plus or minus this divided by 2 is just this. So the zeros are 1 plus square root of 3i, 1 minus square root of 3i. The key thing to note is complex zeros always go in pairs because of the plus or minus. I have 2 of them, one with the plus sign and one with the minus sign. So how does this Descartes sign rule help us? Well, it tells us this now. If these are just the possibilities for negative zeros, there could be 4 of them, but because some of these zeros could be complex, maybe 2 of them were complex, so really they're not 4 negative but just 2 negative. But what if all 4 are complex? Then the number of negative zeros would be 0. Okay, so keep that in mind. Since this Descartes sign rule only tells us the signs, okay, of the rational zeros, what happens if the zeros are complex? That means we have to decrease these positive sign changes or negative sign changes always by 2, because out of those 4 zeros, if 2 of them are complex, then I can't have all 4 negatives, then only 2 of them are negative and the other 2 are complex. So then we have all 4 are complex and we have 0 negative zeros. So we always decrease these positive and negative sign changes by 2. Then we create a chart. Okay. Actually, let's just skip this. We'll just go by this. Let's even ignore all of this that I did. I mean, this stuff is useful to help you check your answers, but since the notes don't cover the Descartes sign rule, we'll just use up to this point. Okay. So we know this, that I have negative sign changes. That tells me these are my negative zeros, and these are my positive zeros. So do I have any positive zeros? No. According to Descartes' sign rule, I have no positive zeros. So out of these choices that I had, 20 of them, I can get rid of 10 of them right away. I can get rid of all the positive ones because I know that my zeros are going to be negative. Okay. So now what do we do? Once we know our zeros, our choices, then what do? We divide by p of x by our choices for zeros in step 3. Okay, so let's do that. So let's divide p of x by our choices. The first choice is -1. I'm just going to go from left to right, except I'm going to use all the negatives because this tells me I have more negative zeros. So I'm going to do that. So my polynomial was what? We had the polynomial that we started with was 1, 3, 23, 56, 52, and 16. So I get 0, 3. -1 times 3 is -3. We get 20. -1 times 20 is -20. So we get 36. -1 times that is -36. So we get 16. And -1 times 16 is -16. Wow, that was good. We found 1 0 right away. Okay, so in this case we lucked out and we found 1 0 right away. Okay, alright, so what do we want to do next? And this becomes a quotient. So my quotient is what now? Q of x is, I started with degree 4, so it becomes degree 3. So we get 3x cubed plus 20x squared plus 36x plus 16. So that's what I end up with. Okay, alright. Then we continue the process again, because if you notice, what did it tell us to do? Repeat the above steps for the q of x that we get. Why do we do that? Because technically, once we find that 0, then my polynomial p of x that I started with can be written as q of x times d of x. Okay, and the d of x is what in this case? Q of x would be this, and then d of x is my x, my 1 0 was -1, so d of x would be the factor. So to get that, you move this over, so we get x plus 1 is equal to 0. So in this case it's x plus 1. So my polynomial that I started with becomes this now. So we started with p of x, that was something really ugly. Where'd it go? Up here. Okay, and that by finding 1 0, we can rewrite p of x as this. Since we found the remainder is 0, we can write it this way, and then I'm down to q of x as this. I repeat this for the same thing. We just lucked out in this case that the last term and the first term are exactly the same as what we had up here. Okay, so we don't have to go through the whole process again. If these were different, let's say this was 4, okay, and then we would have to repeat this, find the choices again, and then start this process again. Do you guys follow? But in this case, we just lucked out that the last term and the first term are exactly the same, so my choices are still the same. So what do? I take this polynomial q of x, which is 3, 20, 36, and 16. I'm working with this now, keep in mind, not with the original one, and doing synthetic division. Start with -1 again. Okay, again we're going to use the negative because we learned earlier that our choices, Descartes' sign rule told us that most of our zeros are going to be negative. So we're going to start with negative again and do the same thing. So we get 0, 3, 1, we get -3, we get 17, we get -17, we get 19, we get -19, we get -3. So that's my remainder. So this is not a 0 since we didn't get a remainder of 0, and we continue this process. Just to save us some time, I know one of my other zeros happens to be -2, which is what the next number I would try. So let's do that. So we get 0, 3, -2 times 3 is -6, we get 14. -2 times 14 is -28. Okay, so we get 8. -2 times 8 is -16, so we get 0. So now this tells me x is equal to -2 is my other 0. Okay, so let's take a look at how to finish this up. Now my quotient is what now? We started with degree 3 this time, so it's degree 2, so we get x squared plus 14x plus 8. Now I can continue doing this process that I just started, repeat steps 1 and 2 again, okay? But I don't need to do that. Once we get it down to a quadratic, we know how to find the zeros of a quadratic, don't we? So we can use a quadratic formula, or we can factor it, or we can do a lot of different things. So in this case, all I'm going to do is anytime you get it down to a quadratic, just set it equal to 0 and either factor or use a quadratic formula. In this case, I want two numbers. When I multiply, I get 3 times 8 is 24, and when we add, we get 14. So the numbers are 12 and 2. And then there's a 3 common, so I can take it out. So I get x plus 4, 3x plus 2 over 3. These cancel. So I'm going to skip a step here. This times this is 0, so that tells me x plus 4 is 0, so x is negative 4. And 3x plus 2 is 0, so that tells me x is negative 2/3. So what are my zeros so far? All my zeros for this problem. X is equal to minus 1, minus 2, negative 2/3, and negative 4. So those are the zeros I found. I wanted to find 4 zeros. I found 4 zeros. Okay. The key thing to note over here is these were all rational. Do you guys see that? Because they are all fractions, because this is 4 over 1, 2 over 1, and these were all in our choices. If you notice, if you go back to our choices that we had here, if you take a look at it, one of the choices was negative 1, negative 2, negative 4, and negative 2/3. They were all there. If the 0 happens to be rational, it's going to come out of that list that we created. If it's not rational, then obviously it's not going to come out of that list. Okay? Alright, let's take a look at another example, and hopefully I'll do 2 more, and that will help you understand these ideas a little bit better. So let's take a look at a simpler polynomial, a smaller one. Okay, so let's say if I have p of x is x cubed plus 3x squared minus 6x minus 8. Okay, now before I do the zeros, remember I did the Descartes sign rule. Let's go ahead and do that right away, so that way we know how many positive zeros we have. Positive zeros and negative zeros. The positive zeros will come from the sign changes in the polynomial that's given to you. This is positive. Did the sign change from here to here? No. But it did change from here to here. You can see this is positive, it became negative. Did it change from here to here? No, it's negative and negative, so it didn't change. So that tells me I have there's a possibility that I have one positive zero. This just gives you the possibility, okay? It doesn't guarantee you that. In this case, we ended up with 4 negative zeros, but it doesn't always guarantee you that. Now to find the negative zeros, you change x to negative x, and across in the whole entire polynomial. So we end up with negative x cubed plus 3x squared plus 6x minus 8. Okay, all I did is cube each of these x's now, and I put parentheses because I was plugging in a negative number. I have a sign change from here to here, negative to positive. There's no sign change here, but there's a sign change here. So there's 1 and 2 sign changes. So there's a possibility that I have more negative zeros. So when I get my choices, I'm going to try the negative ones first, because it looks like I have more chances of having more negative zeros. Okay, so that's why this Descartes sign rule does help to narrow things down. So now let's find our choices. How do we do that? We start by taking the last term coefficient, which in our case is 8, and trying to find all the numbers that divide 8. That's negative 8. What numbers divide 8? Well, plus divides 1 divides 8, so it is minus 1. Plus or minus 2 divides 8. Plus or minus 4 divides 8. And plus or minus 8 divides 8. Then I take my first term coefficient, which in our case is 1, and find out all the numbers that divide 1. In this case, it's just 1. So what are the choices of a rational zero? choices for the rational zeros. Okay, our choices are going to be the last term coefficient, the factors of the last term coefficient divided by the factors of the first term coefficient, right? So in our case, I take all of these last term coefficient factors divided by this guy. Anything divided by 1 is just the same thing. So I end up with this. I have 1, 2, 3, 4 times 2 is I have 8 choices. Okay, now remember what I said. Instead of trying to check all of these choices, I'll start with the negative ones first, because we learned earlier that majority of our choices are going to be negative. So we're going to start with the negative ones first. Okay, so just keep that in mind. All right, so let's get started with the negative ones first. Okay, so to figure out our zeros, we start dividing the polynomial using synthetic division. So you have 1, 3, negative 6, negative 8. 1, 3, negative 6, negative 8. I'll start with negative 1, 0, 1. I get minus 1, 2, negative 2, negative 8. We get 8 and 0. That's good. We lucked out right away. We found the first 0. So one of my zeros is x is equal to minus 1. Okay. Well, what polynomial did we have? Degree 3. So we were looking for 3 zeros. If we found 1 0, then my quotient is what now? My quotient will have degree 2. So we get x squared plus 2x minus 8. Okay. And then we repeat the same process for this polynomial now. Okay, because this is my new polynomial. But because this is degree 2, I don't need to go through this tedious process of finding the cofactors of the last term, first term, and things like that. I can just find the zeros of this by taking this polynomial and setting it equal to 0. That's how we find zeros. It's a quadratic, and that's why I'm doing it this way, because we already know how to solve a quadratic either by factoring or the quadratic formula. In this case, I can factor, so I get x plus 4, and we get x minus 2 is equal to 0. So this product is 0. One of them has to be 0. So we get x is negative 4 and 2. So my zeros in this for this problem are x is equal to minus 1, negative 4, and 2. And these are all rational numbers because this is over 1, 1. Rational numbers are fractions. So my choices are negative 4, negative 1, and positive 2. And that agrees a little bit with our thing that I got 2 negative zeros and 1 positive 0. Okay, alright. So that's how we find zeros. The key thing is you want to get it down to a quadratic. Once we get a problem down to a quadratic, it's easy to solve the rest of the way. It's hard to get it down to a quadratic sometimes. Okay, alright. Let's take a look at another example. So let's say if I have p of x is equal to x to the let's see, find something big. Okay, 2x to the 4th minus x cubed minus 4x squared plus 10x minus 4. Okay, this polynomial we cannot factor this or anything. If we could, we would just factor it and find the zeros much quicker. So the first thing we're going to do is, before we set up about doing the method that we just learned in this section, trying to find the rational zeros, let's figure out the choices for the positive zeros, the number of positive zeros we can have and number of negative zeros we can have. The choices for your positive zero, the possibilities of your positive zeros depend upon the number of sign changes from term to term in the given polynomial. I start with the positive. Positive to negative is one sign change, no sign changes, another sign change, and then another sign change. So I have 3 sign changes. So I have possibility of 3 positive zeros. Okay, that's a possibility. They don't all have to be 3 positive. Some of them could be complex. Okay, like I said before. To find the negative sign changes, you replace x with minus x. So you get 2x to the 4th minus x cubed plus 4 negative x squared plus 10 times negative x minus 4. Okay, So we get 2x to the fourth plus 2x cubed plus 4x squared minus 10x minus 4. So now, how many sign changes do I have here? Positive to positive, no sign change, no sign change, 1, and that's it. So I have a possibility of 1, negative 0. So this problem tells me that in our case I have more positive zeros than negative. Okay? So when I try this method, I'm going to try it with the positive zeros before I try the negative one. And keep in mind, this is just a guideline. You will notice that when we do this problem, what's going to happen is something interesting. But this is a good place to start. So then what do? Figure out our choices. Last term coefficient, the factors of that. I have negative 4. What number divides negative 4? Plus or minus 1, 2, and 4. Then first term coefficient is 2. What numbers divide 2? Plus or minus 1 and plus or minus 2. So what are our choices? I'm going to start abbreviating now. Choices for rational 0. We get x is equal to last term coefficient choices divided by the first term coefficient factors, not choices, factors. So you take all of these last term coefficients, divide by this, so we just get the same thing back. Anytime you divide by 1, we just get the number back. Then you take all of this and divide by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is 1. We already have 1 here, so we don't need it again. 4 divided by 2 is 2. We already have that here. Okay? Alright, so then we start doing synthetic division. So I'm going to start with my positive numbers since I have a possibility of more positive zeros. So I get 2, negative 1, negative 4, 10, negative 4. Okay? I have 0 here, 2, 1 times 2 is 2, 1, 1 times 1 is 1, negative 3, 1 times negative 3 is negative 3, 7, 1 times 7 is 7, so we get 3. That tells me that this is not a 0 because the remainder is not 0. And you continue this, and just for the sake of time, I know which one's going to be. Half is what's going to work here, so I'm going to start, which is the very last one. So you can see this method is tedious. You would have to go ahead and try 2, 4, and none of these are going to work. And then you get to half, but that's alright, it goes fairly quick. So I have 2, minus 1, minus 4, 10, negative 4. I have 0, 2, half of 2 is 1, we get 0. Half of 0 is 0, we get negative 4. Half of negative 4 is negative 2, we get 8. And half of 8 is 4, so we get 0. So one of my zeros is x is equal to a half is my 0. Okay. Now, what is my q then? My polynomial q of x is, I started with degree 3, so I'm down to degree 4. Okay. I'm sorry, I started with degree 4, I'm down to degree 3, so I get x cubed. There's no x squared term, so minus 4x plus 8. Okay, and then I want to find the zeros of this, so we repeat this process. Since this is degree 3, I have to repeat this process again. But before I do that, I notice there's a common factor of a 2, so always take that out if you can. Always take your common factors out. Okay, let me do it this way. Then we want to find the zeros of this, so what do? We take this and set it equal to 0. That's how we find 0. There's a common factor of 2, so let's divide both sides by 2. So we get x cubed minus 2x plus 4 is equal to 0. Okay. Then we're down to this problem whose zeros we want to find. Okay. We don't need to do the sign thing again. We just need to do our choices again. Okay. In the very first problem that I did, after we found 1 0, we ended up with a degree 3, which had exactly the same last term and the first term. And that's not always going to happen. You can see that here clearly. Out here my last term is 4 and my first term is 1. And the problem I started with had a last term of 4 and the first term of 2. So since we have different last terms here now and the first terms. Let's go ahead and find our choices again. My last term factors are what? My last term coefficient factors are what? I get plus or minus 1, 2, and 3. And 4, because that divides 4. And my first term coefficients is 1, so my factors are just this. My choices are for x are what? I'll just abbreviate. Last term coefficient, factors of the last term coefficient divided by the factors of the first term coefficient. Divide all of these by 1, so I get this. And once again, remember we had more positive zeros when we did the sign rule at the very beginning, so I'm going to check the positive numbers again. Okay, and you'll notice that none of them are going to work. So if you go through all the positives, they're not going to work, which is fine. And then you'll start with the negative. So I'm just going to start with the negative just again to save time. But you do have to go through the positives first, because we learned that we had more positive. The point I'm trying to make with this is this thing that we do is just a general guideline. Sometimes it works, sometimes it's not going to work for you, to help you out. Okay, so now we have 1, 0, because x squared term is missing, negative 2 and 4, and then we're going to divide by negative 1. Okay, so we get 0, 1, minus 1, minus 1, we get 1, negative 1, 1, 5, so that didn't work. Then let's go ahead and divide by the next one, which would be negative 2, because I already tried all the positive ones. Assume that I already tried it. So now I'm going to go through the negative ones. You get negative 2, negative 2. So we get 4, we get 2, we get negative 4, we get 0. So that works. So that tells me my other 0 is x is equal to negative 2. So I found 2 of them so far. Now, the good thing is, now my quotient is what this time? Since I started with degree 3 this time, I'm left with degree 2. And I know how to find the zeros of degree 2, right? You take the polynomial and set it equal to 0. This one I cannot factor, so I'll just use the quadratic formula. A is 1, B is negative 2, and C is 2. So let's use the quadratic formula. So you get, write the formula down, minus B plus or minus square root of B squared minus 4AC divided by 2A. So we get minus of minus 2 plus or minus negative 2 squared minus 4 times A times C divided by 2 times A. So we get 2 plus or minus, we get negative 2 squared is 4 minus 8, because 4 times 2 is 8, so we get negative 4. So negative 4 over 2. I know that square root of negative 4 can be written as what? 2i. We've talked about that enough times. And then anytime you have complex numbers, we want to separate the 2 on the top, so we get 2 over 2 plus or minus 2 over 2i. So you get 1 plus or minus I. So these are my other zeros. I have 2 of them. So all my zeros, let's write them down. The zeros were what? X is equal to 1/2. Then we found negative 2, and then 1 plus or minus I. The degree of the polynomial was 4, so we were looking for 4 zeros. 1, 2, 3, 4. One with the plus sign, one with the minus sign. Now here, this is my positive 0, and this is my negative. So it looks like I didn't get 3 positive zeros. That's because I got only 1 positive 0. The other 2 positive zeros ended up being complex. Okay, so this idea of the sign rule doesn't always work, but it is really a place to start to narrow your choices down. Okay, so just keep that in mind. Sometimes people get frustrated with the sign rule, but it is a place to start to narrow your choices down. Okay, alright. And you can do the same thing with just about any polynomial if you would like. I can do one more example just to drive home the point. Let's do one last example. Okay, let's say if I have p of x is equal to x cubed plus 3x squared plus x plus 3. Now this one I can easily solve by factoring. You can clearly see that. Okay, so it's not a very good problem to use this method on, because I have 4 terms I can group, and I can solve this very easily by factoring. So let me pick a different example. Okay. Let's see, we have x cubed minus 6x squared plus 13x minus 20. Okay, so the first thing we should do is do the sign thing to figure out how many positive zeros I have and how many negative zeros I can have. So the positive zeros are, look at the sign changes here. This is positive, the sign changes from positive to negative, negative to positive, positive to negative. So I have 1, 2, 3 sign changes. Now to figure out the negative sign changes, you replace x with minus x, so you get negative x cubed minus 6x squared minus 13x minus 20. So how many sign changes do I have now? 0. So the number of negative zeros are going to be 0 because I have no sign changes here. So that tells me that I have no negative zeros in this problem. So that's a nice thing to know. So let's find our choices. The last term coefficient factors are, this is negative 20. What divides negative 20? Plus or minus 1, 2, 4, 5, 10, and 20. And the first term coefficient is 1. What divides 1? Just plus or minus 1. So what are my choices for 0? Choices for rational zeros are x is equal to the factors of the last term coefficient divided by the factors of the first term coefficient. So you take all of these and divide by 1, so we get 1, 2, 4, 5, 10, and 20. And we already know we have no negative zeros, so we can ignore all the negatives. So even though we have 1, 2, 3, 4, 5, 6, 6 times 2 is 12. 12 choices, we really only have 6 choices. So we only need to worry about the positive ones. Okay. Again, I do want to stress this. In this last example, if you notice, we found 2 rational zeros, 2 fractions, and the other 2 were complex. So these were rational and these were complex. So the rational zeros were in our choices. If you notice, our choices were up here. Okay. Oops, that's a wrong example. Oh, that was the right one. So our rational zeros were half, negative half, and positive half and negative 2. And so they were in our list. If we find a rational zero, that is going to be in the choices that we create. Okay, the only thing that are not going to be in the choices are zeros that are not rational, like square roots or complex. So because we know we have more positive here, so let's just divide everything by positive zeros, by positive choices. So I'll start with 1. Okay. Actually, just for the sake of time, I know that the only one that's going to work is 4. So this is not going to work and this is not going to work, but you have to try them because you don't know that. I know that. Okay, because I picked the problem. So 4 is the one that's going to work. So we have, my polynomial is what? 1, negative 6, 13, and negative 20. So I get 0, 1, 4 times 1 is 4, we get negative 2, 4 times negative 2 is negative 8, so we get 5, 4 times 5 is 20, so we get 0. The nice thing is this tells me that x is equal to 4 is a 0, but because we found 1 0, okay, we don't need to do any extra work beyond that in terms of doing this method, because now I'm down to degree 2. My quotient is going to have degree 2, so I get x squared minus 2x plus 5, since I started with degree 3. I know how to find the zeros of this. All you have to do is take this polynomial and set it equal to 0. It's degree 2. If you cannot factor it, we can use the quadratic formula, which is what we need to do here. B is equal to negative 2 and c is 5. So we get x is minus b plus or minus b squared minus 4ac over 2a. So we get negative of negative 2 plus or minus negative 2 squared minus 4 times 1 times 5 divided by 2 times 1. So we get 2 plus or minus square root of negative 2 squared is 4. And then so we get 4 here, minus 4 times 5 is 20, so we get negative 16 over 2. What is square root of negative 16? Which is square root of 16 times square root of minus 1, which will be 4i. So we end up with 2 plus or minus 4i over 2. We have to separate the numerator and the denominator. So we get 1 plus or minus 2i. 2 divided by 2 is 1, 4 divided by 2 is 2. So what are my zeros here? I found x is equal to 4, 1 plus or minus 2i. So I got 1 with the plus sign, so that's 2, 1 with the minus sign, so that's 3. So I got 3 zeros. Okay. So I hope these examples will help you do the homework problems. This is a very specialized method, and you won't believe it, but as we get into upper division math classes, some of you who will take those, you will see this method again, because there are times when we need to find the zeros and there's no other way to find the zeros other than doing this. Okay, so just keep that in mind.